All right, so a couple of people asked for help with limits number 1, part 2. So if you had trouble getting started, watch as much of this video as you need to, and then stop and finish it on your own. So it asks for the average rate of change of temperature over each interval. So average rate of change is always going to be this formula, f of b minus f of a over b minus a. That gives you average rate of change over an interval, all right? And that's the same as the slope formula. So in this case, that's going to be t of 4 minus t of 2 over 4 minus 2. So I'm sorry you couldn't see that before. This is where I'm getting this. And then I've just plugged in 2 and 4 for my a and b. Okay, so to make things easier on myself, I went to my y equals, and for my y1, I put in the function that we're dealing with here, 37 plus 3.1 t squared. All right, so that way when I go back into my calculator, I can start with a fraction thing, alpha f1 to get the fraction. You know, there's different ways to do that. So I'm going to go vars, y vars, function y1, and I'm going to go of 4. And then I have minus, I'm going from this equation here, minus vars, y vars, function fy1. And then of 2. All right, and now I'm not going to have to do that again because from now I can copy. Now the denominator I have 4 minus 2. In the calculator I'm just going to put 2. I hit enter and I get 18.6. So I'm going to say that is 18.6. Now by the way, this is a rate of change of temperature. This is measured in degrees centigrade and time is in minutes. So this is degrees centigrade per minute. That is the average rate of change over the interval 2 to 4. So now we're following the calculus way of doing things where we take a shorter and shorter interval to try and our goal is to understand the exact rate of change at t equals 4. So my next one is at 3 to 4. So I'm going to go t of 4 minus t of 3. And if you get the idea, then stop the video and see if you can finish off the rest of these before you continue. So now I'm going to go up here and I'm going to copy this by highlighting it and then pressing enter. And then I'm just going to change the 2 to a 3. So we'll just make that 3. It just types right over. Bajwinga. And I get 10.85, which is not really the number I was expecting. Oh, I know why. Because now the denominator is 3 minus 2. Did you catch my error there? So the denominator is 3 minus 2, so this denominator should be 1, not 2. So down here, I should have 1, and I have 21.7. I like that number a lot better. So that's going to be 21.7 degrees centigrade per minute. All right, and then it says 3.5 to 4, so I can just copy this and change my 3 to a 3.5. And this time I'm going to remember that the denominator is now, oh, let me write this out to be consistent. T of 4 minus T of 3.5 over 4 minus 3.5. Geez, this should be 4 minus 3 right there. Right, because B minus A, 4 minus 3. Fortunately, it's still 1. Okay, now this time I'm not going to forget to change my denominator, though. My denominator of 4 minus 3.5 is going to be 0.5. And then I hit enter, and now I got 23.25. So this equals 23.25 degrees centigrade per minute. All right, and my last one is going to be T of 4 minus T of 3.9 over 4 minus 3.9. This is how we do average rates of change. And notice we're just taking a smaller and smaller interval that is has 4 as an endpoint. So this time I'm going to copy this up here. I'm going to change my 0.5 to 0.1 because 4 minus 3.9 is 0.1. And then in my numerator, I'm going to change 3.5 to 3.9. And then I get 24.49. So that's 24.49 degrees centigrade per minute. All right, so that's all the average rates of change. You can think about what's going on here as I have a time interval that is ending at 4. My first time interval is using 2 seconds to 4 seconds. My second time interval is using 3 seconds to 4 seconds. So this time our intervals are not centered at 4 like the ones we did before. But this is actually how we're going to do the calculus a lot, because it turns out that as long as you have smaller and smaller intervals that all contain your goal of t equals 4, then it's still going to work. So I'm taking smaller and smaller intervals centered around 4. 4. So we'll see how we do number 2 in the next video.